Hello class, today we're going to be looking at polynomial functions. Today's characteristic, we're looking at end behavior. So let's jump right in. First we're going to define what a polynomial function is. If we let n be a non-negative integer, that means it's positive and there's no decimals and no fractions, then we have several little real numbers that will become our coefficients. They're going to be real numbers, and that first one, a to the n, is not going to be 0. Some of the others could. And then we define our polynomial function as the function f of x is equal to a sub n x raised to the nth term, nth degree, plus a n minus 1 x raised to the n minus 1, plus, and we can have any number of terms in this polynomial, plus a sub 2 x squared plus a sub 1 to the x plus a sub 0. And that would be x to the 0, but x to the 0 would be 1. Let's just give a real quick example of what that might look like in real numbers. So here's an example. F of x is equal to 7x to the 8th minus 16x to the 7th plus 2x to the 6th plus 15x to the 5th plus 3x cubed minus 2x squared plus x minus 82. Notice we didn't have an x to the 4th in there. That's because that's coefficient is 0. And we'll address that in a little bit. So this is a polynomial function with x of x with a degree of n. And in this example, the degree of that polynomial is 8 for this one. So, and what I want to do here is then the coefficient, that a to the nth right here, and the coefficient of that term is 7. That is called the leading coefficient. It's the leading coefficient because it's the coefficient of the leading term. Now we are going to be getting to graphing these, and when we do graph them, they create a smooth, continuous curve. There's no breaks in them. We don't pick up our pen, so they look, they're fun little things like that. So let's take a look at the leading term test. So we're going to use that leading term test that we just went over to determine the end behavior of x to the 4th minus 4x squared. This is my leading term. So the degree of this leading term is 4, which is even. And the leading coefficient of this term is 1, which is positive. So it has end behavior that look like this. So we're going to say that as x moves left, y rises, and as x moves right, y rises. The other way of writing that would be to state x approaches negative infinity, y approaches infinity, and as x approaches infinity, y approaches infinity. That's one other way of stating that. Let's take a look at another one. This one, the leading term is a little bit hard to find. The leading term, when you have multiple factors, is going to be the multiplication of all the leading terms of these factors. So the leading term is going to equal negative 2x cubed times x times x. So we're multiplying this term, and this term. So our leading term is going to be negative 2x, and that's cubed and 1, so that's x to the 5th. This is the term we're going to use for the leading term test. Now the degree is 5, which is odd. And the leading coefficient is negative 2, which is negative. So when it's odd and negative, it's going to have the end behavior that looks like this. So I will state, as x moves left, y rises. As x moves right, y falls. We could also state it as x, as x approaches negative infinity, y approaches infinity. And as x approaches positive infinity, y approaches negative infinity. And you're going to try a few of these tomorrow.